Solid Edge continues to deliver enhanced workflows, promoting greater performance and increased productivity. Here we have the world's first contactless robot bar, designed and manufactured by Solid Edge startup customer Yanu. Introducing a fresh, modern user interface which is consistent across all Siemens software products, all commands and environments have been refreshed and now provide an easier-to-use, modern, clean look and feel, but still at the core, the Solid Edge you know and love. The Context toolbar now has expanded capabilities in the part, sheet metal, and assembly environments, providing high-frequency, object-specific commands at the tip of the user's cursor, improving productivity. Focusing on the robot arm, we'll complete the new design of a glass holder. The material addition and removal workflows have now been combined into one single command. Also new is the introduction of the automatic regions in ordered sketches. This speeds the process of sketching as it eliminates the need to trim sketch elements and project face edges. Closed areas are simply found automatically, as can be seen here, as we add and remove material with a single extrude command. Also notice the Context toolbar delivering all commands at your fingertips. Changing an extruded feature to a cut couldn't be any simpler. Just edit the feature and change the options. When adding features, the spacebar can also be used as a quick toggle to switch between add and remove. Solid Edge speeds up the process of direct editing in an ordered model by introducing synchronous capabilities in the move, rotate, and offset face commands. Here, the steering wheel is used to easily define the move and rotate directions, and design intent rules can be used to control the movement of the other faces in the model. We can see this as we adjust these two cylindrical faces and toggle the concentric option off and on. One final alteration on this part is to add an angle to the side face by using the rotate command. The enhanced workflow makes this a breeze. Since this is an ordered model, the move and rotate features are captured in the Pathfinder and can easily be edited later. The hole feature capabilities have also been extended and now have support for standard fit class tolerances for hole, countersink, counterbore type holes. These conform to ANSI, ISO, and DIN standards. Support for unit tolerance has also been added, as well as a new library of high-quality face styles which consist of many common categories containing thousands of different styles, ranging from additive manufacturing, coatings, fabrics, plastics, metals, and many more. They can simply be dragged and dropped onto the desired parts to easily add realism to any design. There have also been improvements to assembly features with the addition of new commands such as subtract, slot, union, and swept cutout. In this case, we'll add a swept cut to document a routed path through two wooden plinths at the top of the design. The workflow is the same as in the part environment, but with the additional step of choosing the parts to cut. Finally, there are new workflows to easily explore and visualize the internal components of any design with a new Visual Explode command. Simply drag the slider bar to dynamically explode the parts on screen, then drag it back to collapse the parts back into place. There is also a stepwise option which intelligently explodes the subassemblies in sequence and provides additional ways to visualize the design. Solid Edge continues at the forefront of 3D CAD and remains ahead of the curve thanks to increased core CAD performance, new and improved workflows promoting productivity gains, and the continuous implementation of user-requested features and functions.
Solid Edge provides new advanced PMI and model-based definition capabilities, allowing users to detail 3D models faster and easier than ever before, and to seamlessly share 3D model intelligence for downstream manufacturing processes and to other relevant stakeholders. New with Solid Edge Advanced PMI is the ability to automatically arrange dimensions on a 3D model with a couple of clicks. Simply select the needed dimensions and arrange them stacked or chained. If dimensions need to be arranged with respect to a smaller area of a model, there is an Arrange to Area option which makes this task easy too. This part lacks the necessary dimensions for the size and location of some of the holes. The new Auto Dimension capability takes care of this with ease. All we need to do is select the primary, secondary, and tertiary planes and select the features to be auto-dimensioned or even just auto-dimension the whole model. With support for planar faces, cylinders, and holes, it's never been easier to save time in dimensioning your model. We can even define tolerances to be automatically added to each dimension. The new Model View palette allows for fast interaction with model views and displays easy-to-understand thumbnail images which are directly derived from the model views themselves. Model views can be navigated by clicking on the images or using the arrow keys. It's also easy to create new views directly from the palette. Here we'll create a front view for our part to add some of the necessary dimensions to detail the overall height and thickness of the part, and also add a geometric tolerance for flatness. With new text box and notes library features, we can more easily add notes to the model views. These notes can include model properties, like the latest revision of the part in this example. There is also an option to keep the text parallel to the screen. The creation of drawings is a breeze through the new Model View palette. A right mouse click and selecting a template is all it takes to create a drawing. The same Model View palette can also be used in the draft environment. We will use it to bring in the front view and use the alignment function to ensure it's in the right place. The fit class and tolerance of holes can now be easily retrieved in callouts. Also, the ability to modify the color of cut faces on section views means it's even easier to differentiate internal details of a model and communicate necessary product manufacturing information. 3D Center Access annotation is now supported for appropriate geometry types, giving users a quicker way to add the desired product manufacturing information to their models. Section view dimensions in sketches are now associated to the design body, making it easier to use them in downstream processes. The copy to PMI workflow has also been improved. Now when copying selected 2D annotations and dimensions from a profile-based feature or sketch, once they become 3D dimensions, they are now automatically connected to the corresponding model faces. Selecting the PMI will highlight the associated faces. Solid Edge model-based definition allows designers to publish all this product information for use in downstream processes. This process is simple and easy, and the publish process creates a high-quality 3D PDF which contains all chosen model views and supports full view manipulation. Assembly documents can also contain a fully interactive bill of materials and much more. Solid Edge Advanced PMI and model-based definition capabilities provide new streamlined tools to detail 3D models faster and easier than ever before, and to seamlessly share 3D model intelligence for downstream manufacturing processes and to other relevant stakeholders. Quality inspection is an important competitive factor. Using Solid Edge Inspector makes inspection planning a quick and easy process. Taking a look at the side plate in the Yanu AI robotic bartender will open the drawing that already has all the relevant manufacturing information defined. Launching Solid Edge Inspector, we can set the tolerance standards required. If needed, multiple tolerance tables can be configured, which can later be applied based on part type. Creating characteristic numbers with balloons is a quick and easy process. There is also the flexibility to create balloons manually or ignore some specific dimension types. Based on the standards and configurations which have been set here, the default tolerances get applied for the dimensions which don't have specific tolerances defined. These dimensions are highlighted in yellow in the characteristic table. At any time, the dimension class can be controlled to define how critical they are. The inspection balloons can also be shown or hidden when required. This inspection information can be exported into multiple file formats, which can later be used in downstream applications. It's also possible to export this information as a separate project file, which can later be re-imported into the drawing. This is very useful in situations where the quality team doesn't have write access to the CAD files. Inspection reports can be generated by choosing a template that can be easily configured for any industry standard. The inspection data can also be easily updated to accommodate any design changes. Here, a change is made to the model in the drawing, then subsequently updated. At this time, we'll also delete a dimension and add a new dimension. Then a click of a button updates the inspection data. This will add a balloon to the new dimension and update the CN list with this and all the other changes that were made. The changes like modified, new, and deleted dimensions are captured as part of the CN list. Filters can be applied to these columns similar to Excel. As the design has been modified and the drawing updated, we'll generate the inspection report and see the updates. The list shows new, modified, and deleted dimensions. Filters can also be applied to the CN list to generate a compare report. This shows only the changes that were made when compared to the previous revision. Solid Edge Inspector also fully supports a model-based inspection process. This means it works seamlessly on the 3D model in an MBD workflow. Just like we saw for the 2D drawing, it's possible to create and edit balloons and generate a report on a 3D model using the PMI dimensions and annotation. Solid Edge Inspector, providing a competitive edge by streamlining the quality and inspection planning process.
Solid Edge is even more tightly integrated with other downstream processes and now has the ability to transfer assembly kinematic information to applications such as NX or Process Simulate in order to perform further dynamic studies or operations. In this example, we save time and minimize errors by transferring the motion kinematics of this robot arm from Solid Edge to Process Simulate. Starting in the Solid Edge motion environment, we'll make sure the kinematics are properly defined by selecting the parts, then choosing which ones are moving or fixed. This creates the 7 needed joints to replicate the 7-axis Panda robot. Once this is done, the motion of the robot can be verified by running the basic simulation. Now, the Solid Edge model can be exported complete with all the appropriate kinematic information and subsequently opened in Process Simulate. Once in Process Simulate, we can see that by using the Joint Jog option, all the relevant kinematics are present without having to do any additional manual setup work. The kinematic information of all the joints can be viewed by setting the modeling scope and using the kinematic editor. Here, kinematic relations are used to define the robot and simulate the reach movement. We can see that all the joints are correctly connected with each other in the sequence that was defined in Solid Edge. The movement can then be defined from the tool center point frame using inverse kinematic movements that are calculated automatically. Finally, we can simulate the action of the robot and see the exact movement needed to mix our drink of choice. Solid Edge increases productivity by providing even closer interoperability and integration with other solutions in the accelerator portfolio from Siemens, such as Process Simulate and NX Mechatronics Concept Designer.
Solid Edge continues to accelerate the design process by providing powerful tools to help digitally validate designs and build better products in less time by front-loading the simulation process. Starting with the generative design study, which will help optimize the weight and material usage for this cast-to-reel component. After creating a new study and defining the loads and constraints, we have the new ability to define the maximum displacement for a point on a given face. This helps guarantee the model has the appropriate amount of stiffness in a given direction. Also, planar symmetry is a new shape constraint that optimizes the model across 1, 2, or 3 orthogonal planes. This ensures the optimized model will result in the best possible symmetric design. Viewing the results, we can see that both sides of the model are identical to the planar symmetry constraint. Selecting the Show Stress option gives immediate feedback on the areas of high stress concentrations so that we can adjust our model if necessary. The optimized generative design is a unique hybrid model that combines BREP and mesh geometries, which can be sent directly for additive manufacturing. Moving to structural simulation, Solid Edge now supports the ability to analyze these hybrid mesh and BREP models. This allows us to easily validate the results of the generative study by applying the same loads and constraints to a new study. The body mesh option, which is now available in the part assembly and sheet metal environments, has some new options which allow the resulting mesh to be simplified and improved by defining parameters such as the number of points around a circle. In addition to producing a good quality mesh, it provides automatic geometry cleanup of small faces and edges. After solving, we can analyze the model and see that areas of high stress match the results we saw during the generative design study. A new Check Element Quality command has been added, enabling us to view and report any poor quality elements created when meshing. There are 14 Nastran quality checks available. Here we're checking the tetrahedral aspect ratio, or ratio of longest to shortest element edge. Selecting Show Elements highlights and displays the warning and error elements in the model, as well as generating a report containing a summary of error elements. There are no errors in our mesh, but a few warning areas could be improved in a future study if needed. A great usability enhancement is the ability to reuse an existing mesh. Here, we'll duplicate our study and bring the mesh with us. We want to test the model again, but with a higher load this time. By reusing the mesh, we are able to save valuable time by not having to remesh the same geometry. This enables us to quickly run multiple iterations of our study, ensuring the design meets all of the necessary requirements. Solid Edge further enhances our robust simulation capabilities, saving valuable design time and reducing material and testing costs.
Transform your manufacturing and maximize your design data with the powerful automated tools of Solid Edge's fully integrated CAD/CAM solutions. Starting with some 5-axis machining, we'll focus on this part. Since it has features on all sides, a 5-axis approach will allow it to be machined in a single setup. The fixture has also been designed completely in Solid Edge. This is using a window frame technique where the stock body also serves as the holding device. A single button click sends the whole fixture and part to Solid Edge CAM Pro. Opening an existing setup reveals some CNC programming work that has already been done. Solid Edge Cam Pro now supports the adaptive roughing cut pattern for 5-axis roughing. This means very efficient machining and expert control on the stress of the cutting tool, which extends tool life as a result. Here, we'll also look at the machining simulation. This is another great innovation in Solid Edge Cam Pro, the ability to perform G-code-based simulation. Here, the machine motion on the virtual machine is being driven by the actual G-code file. We can visualize all the axes tracking while the G-code file is being run, a true example of leveraging the digital twin. Another great enhancement in Cam Pro is the addition of Smart Machining Kit Simulation within the PostHub portal. There are packages covering 3, 4, and 5-axis G-code simulation. Each package provides access to all the machines in that group. Also, PostHub can now be a repository for things other than post-processors. For example, best practice documents, technical libraries, and much more. Another new capability is the ability to perform rotary roughing on 4-axis machines. Not only is the operation easy to use, but as the machining simulation shows, it does a great job with this spiral groove or any other 4-axis feature. Solid Edge Cam Pro also introduces a brand new wire EDM capability. This makes programming these operations a breeze. Transform your manufacturing and maximize your design data with the powerful automated tools of Solid Edge's fully integrated CAD/CAM solutions.
Solid Edge 3D Publishing speeds the process of creating compelling and engaging technical documentation, such as installation, maintenance, and instruction manuals, which are essential to business success and product performance. Let's dive into the creation of this document for our Yanu AI bartender. With a fresh, updated user interface, with improved performance and a modernized look and feel, creating documents with Solid Edge Technical Publications is a breeze. A New Pages tab allows for easier navigation of documents. With a thumbnail image available for each page, users can now navigate their document by clicking the thumbnail to go directly to that page. Also new is the ability to assign rich text to metadata and illustrations. Here, text can be fully customized to fit your needs. Animations play an important part in conveying different messages and features in documents, whether marketing or instructional. Here, a new transition editor makes it easier to create custom transitions with user-defined timing for camera movement, part reveal, and other animation features. There are also 2 new animation types, flash and fade. Here, a flash animation is being used to highlight the LCD screen, and then a fade animation slowly hides the screen in order to focus on the robot arm in its animation. Also new is the ability to use simplified parts and assemblies, family of parts, and family of assemblies. For the Yanu instruction manual, we'd like to hide some key details on some of the parts in order to protect our intellectual property. To do this, we can easily replace the detailed parts with their simplified representations. This is achieved with the update command. Solid Edge 3D Publishing then takes care of replacing them in our model, all achieved quickly and easily without having to recreate the document from scratch. Users can now define multiple master pages to help with document creation. This provides more versatility in larger documents. Shapes can act as fully actionable items in Solid Edge Technical Publications. Users can customize them for various purposes such as switching illustrations, customizing views, or even directing to web pages. In this page, we can use the buttons to switch between different colors of the Yanu AI bartender. Documentation can be published to all the latest industry standard file types, including 3D PDF, HTML5, raster, and vector images. Here's the completed instruction manual in HTML format. End users can access this information without any additional software, as it will open in any web browser. With Solid Edge Technical Publications, creating technical documents and interactive manuals has never been easier.